We will talk a little bit about our experience doing the CKAD exam. But first, the agenda for the talk. First, a short introduction about us. Then some information about the general structure of the exam. Then we will go over all the topics that are part of the curriculum of the exam. And at the end, we will give you some tips how to prepare for the exam. And at the end, we also give our opinion, what we think about the exam after doing it. But first, to us, my name is Florian Fromm. I'm a cloud and DevOps consultant at Persitence. Carsten, would you also introduce yourself?
Yeah, sure. Yeah, also hello from my side, Carsten here. A brief overview to my person. I have studied computer science at the Saarland University in Saarbrücken. My focus here was machine learning and NLP and computer vision. And since last year, I'm an IT consultant in Frankfurt am Main and colleague of Florian. I made my first steps in Kubernetes in a project in the automotive sector. Here we used a custom ETL solution using Argo workflows, a very cool workflow orchestration framework for Kubernetes. Maybe some of you guys know that. Yes, thanks for having us today. And I would hand back to Flo. He will give you some basic organizational information about the CKAD.
Yes, and also I should share some words about Persitence. So we are also a small consultancy startup, let's say, founded last year. We are currently 20 people, but we have so much work. We want to grow to 50 people till end of the year. So we are really looking for new colleagues. And if you like Kubernetes, you're probably a really good fit for us. So if you are interested, feel free to reach out to me. I'm also an HR manager at Persitence. Okay, but enough shady advertisement. Let's start. So first, it could be that you never heard of any Kubernetes certificates. So for these people, a short information regarding that. There are official certificates handed out from the Cloud Native Computing Foundation. They are free. We have the Certified Kubernetes Administrator. It is for the guy who operates and maintains the Kubernetes cluster itself. Then we have a pretty new one. I think they released that last year. It's the Certified Kubernetes Security Specialist. And I have not much information about it, but it seems to be obvious it's about security. And then we have the one we want to talk about today, the Certified Kubernetes Application Developer. And interesting side note for company people here or people who own a company, if you have 3 people with the CKA certificate, you can also claim the title Kubernetes Certified Service Provider from the Cloud Native Computing Foundation. Sadly, just for the 3 CKA people. But okay, back to the Certified Kubernetes Application Developer certificate. In the end, if you have the certificate, that just should prove that you are able to design, build, configure, and expose applications for Kubernetes. That means in the end, it addresses the guy who, let's say, deploys his application to Kubernetes and operates it there. It's not for the guy who maintains and operates the Kubernetes cluster. And there's also this distinction in the Kubernetes documentation. They always differentiate between the admin and the application developer. And that's the exam for the application developer, sorry. Okay, important question, what does it cost? Just $300, but you get 2 attempts. But the sad part is you don't get any real learning material, so you have to probably also buy that, but we will come back to that point later. And there's a good tip from our side. We also did that. If you attend KubeCon, I can't promise that to you, but at least till now, every year you could get a 50% off coupon at KubeCon. So even if you're not interested in KubeCon, but you should be interested in KubeCon because it's pretty cool. But even if you're not interested, you can save a lot of money by just attending and getting that 50% off coupon. Some meta information about the certificate exam itself. The scope of the thing is you get 4 clusters and 19 exercises on these 4 clusters. You have 2 hours time to do these exercises. And in the end, you have to score at least 66% of the total score to get the certificate, let's say. And that's also an important point you probably already see here. The hardest thing about the exam is the time pressure. It's really hard to get all 19 exercises done in these 2 hours and also to have all the 19 exercises correct, let's say. But, oh yeah, sorry, one additional information. I wasn't sure where to put that, so I put it here. During the XSM, you have one browser window where you have your, let's say, web-based shell, and you're allowed to just have one additional tab open. So they monitor your stuff. You have to install a plugin so the guys can spy on you. And that's obvious. The obvious choice here, the only sane choice, is to have additionally open the Kubernetes docs in the other tab, as a backup. Then another interesting thing is, at least if you compare the certificate to the Azure or AWS certificates, it's a practical exam. It's very different. That's not a multiple choice exam. You really have to do stuff on Kubernetes, and that means you really need Kubernetes knowledge, and you also need practical skills. I first have written there coding skills, but it's not true. You don't really have to be able to code or something like that. But you should be able to use Bash. You should be able to use Vim. It doesn't have to be Vim, but in the end, you are working in a shell, so you have to be able to edit text files in a shell. And yeah, Vim is an obvious choice, and it was also part of every tutorial I could find. And yeah, I also use Vim at work, so it was an obvious choice. And yeah, the best advice we can give directly at the beginning, you have to practice a lot to be sure to pass the exam. And the question could now be, okay, what to practice besides Bash and Vim? It's not that hard. Imperative Kubernetes commands are very, very important for the exam. So that could be an example exercise you get. So they tell you, hey, deploy a BuzzyBox pod, call it BuzzyPod. It should have set an env variable, and it should run command env. The thing is, you could now start to try to look through the Kubernetes documentation, but you won't find exactly that YAML definition you need. You could now start to copy different YAML definitions into each other, but that is very error prone, and you get really fast into big trouble. So you should use an imperative command, because with that command here, it could look a little bit scary to you if you've never seen something like that, but it's not that hard. You learn it really quick. You can generate this whole YAML you need, and there's not much chance to have any indentation errors or something like that. So, and it's fast, much faster than reading documentation. So in general, to pass that exam, you really need to practice and learn these imperative Kubernetes commands. Also, okay, the link is not that useful in the presentation, I know, but you can also Google for GitHub and CKAD exercises. It's a beautiful GitHub repo where they have listed a lot of these short exercises, and they also show you the imperative command to solve them. So it's very good for learning. And I now think I hand over to Carsten.
Yes, thank you. The scope of the CKAD is the interaction with an existing cluster. You are not supposed to configure a cluster or initialize it. You only need to create and adjust Kubernetes objects. These are in particular pods and deployments, services. You need to know how to enrich pods with config maps and secrets. And of course, that is a very important topic here. You definitely need to work with persistent volumes and persistent volume claims. Next slide, please. This is the official topic distribution by the foundation. Given that, you can more or less predict what concepts are important here. That means you will see single container pods, multi-container pods, networking through the cluster, and as I said, state persistence. This is very important. And in the following, I will guide you through some sample questions for each of those topics here. I hope it's not too long-winded or boring for you guys, but I hope I can give you a feeling of the complexity of these tasks. So Flo, next slide, please. Yeah, one important note here, Florian has mentioned it before. You only have 2 hours to complete the entire exam. It sounds much, but it isn't. You really need that time. So you want to make sure that you are quick and you can solve these exercises very quickly. So the very, very, very first thing you should do once you enter the cluster, just 2 commands here. Create one alias to shorten your kubectl base command to 1 letter, which saves you some second here. And another one, which I will present later on, is create an environment variable do, which basically means this is a suffix for some creation commands for Kubernetes. With that command, you can just create an object without deploying it to the cluster. This is this dry run client part here. And on the other side, you want your code in YAML file. We will see that later on. You need that to create a YAML file representing your object you want to create. And after that, you can enter that file with Vim, and then you can adjust some last steps before you deploy your objects. Good, then we are done. Let's dive into these questions here. This could be the first question in your example, in your exam here. This is very straightforward. It just says, dear user, list all namespaces in the cluster and save this list in that file here. Next slide. And you can just basically type kubectl, get my namespaces, and redirect that output list into my file they have specified for you. And this is basically it. This could be a first exercise. Get your points, do not make mistakes here, and you can head to the next question. And then you will definitely see something like that where you have to just create a pod here. The first thing you have to do, read that description of your tasks very carefully. And one additional bony here, you have a notepad in your exam environment. Take some notes, just add all the information you need, and then you can start. In this scenario, we just need to create a pod with Alpine in the default namespace. This is a good point. Always double check your namespace. You have to work in different namespaces. It's obvious for obvious reasons. They want to have to let you have a good overview over your objects in these namespaces. So they are partitioning the objects between those namespaces, and always make sure you work in the correct one, because it would be very, very annoying if you deploy an object in the wrong namespace. Yeah, here we have to create a pod called pod1 with a container called pod1 container and an Alpine image. After that, you just need to write a script that outputs the state of this pod. So let's go on. Flo, next slide. As Flo said, I can't emphasize this enough, and I will repeat that later on in the talk. Do not write a YAML file from scratch. You won't have time for that, and it's the chances making errors, like indentation errors in a YAML file, are too high. Just use imperative commands here. And an example would be kubectl run, then a pod1, this is the name of the pod, with an Alpine image. And then we take our environment variable do, which say make a dry run, do not deploy it, and output all the specification in a YAML format. And then we redirect it to a file which we will create. Then, Flo, next slide, we can open that file. And this is the fantastic thing about imperative commands. You have everything you need. Kubernetes provides you all you need for that. There is no need to create a YAML file on your own. So just go along and change the container name, which is the only thing that is missing here. By default, Kubernetes names the container the same way as the pod. That means by default, it is pod1, it's named pod1. So just add the minus container here and you're good to go. Next slide. Please do not forget to deploy your objects. It would be extremely annoying if you did your work, you created your YAML file, and then you forget to deploy your object. Just do a create, do not forget that. Then for double check, you can just say, could you please go to the last slide? We just have a look at our pods and see, okay, it is up and running, and then let's rush to the next exercise. Next slide. Yeah. And one additional remark here, the tasks invites you to create a shell script. So this is important here. Flo has said it. You need to be able to work with the bash. So don't be surprised if you see something like that, something that is off-road of the Kubernetes tasks. Don't be surprised. It's just an easy task. Create a shell script and just put a command in here which gets the description of your pod1 and just grab for the status. Next slide. Then you have something like that when you execute your shell script. So don't be surprised if the task wants you to do something like that, some Unix stuff. It's not very hard, and yeah, then we can go on to the next exercise. Yeah, that's it about the core concepts. Now we go to the configuration part. I think it's very likely that you have to do something with configuration. To be honest, for me, it was always a bit of a pain in the ass to work with config maps. But once I have seen the beauty of imperative commands, everything has changed. In this scenario here, we are working on the namespace Moon. We have a deployment called WebMoon. And there is something going on here. There was some error. Because it seems that the deployment was not correctly configured, and so they want you to create a config map to solve the problem. Next slide, please. If you have a look at one of the pods from the replica set of the deployment, if you pick one out and have a look at it, then we see, okay, it seems that the config map was not mounted properly. So we have the evidence that this config map is not present in the cluster. So we need to make sure that it is. Next slide. And again, we use imperative commands. Do not forget your namespace Moon here. We have as namespaces, we have the planets of our solar system. We are at the Moon namespace now, and we create a config map. And we are supposed to create a key called index.html with the content of the file located at opt course 15, etc., etc. And the good thing about that imperative command is you can just say, dear config map, I want my key here, and as the value for that key, I want the content of that file. If you would not use imperative commands here, you would need to copy and paste what is inside of that file, and you will definitely don't want to do that, because that can really be a pain in the ass if you work with Vim. So just make sure that you use something like that. The same thing works for secrets, I guess, or you can do you can add some literals here and give the value directly to the command line. It's very, very easy. And if you work with secrets or config maps, you definitely want to use imperative commands here. So next slide. And then this outputs you something like that. And imagine you would have write that on your own. You don't want that. You don't have time for that. So just use the imperative command. Next slide. Yeah, then to double check, you do not need to do that, but for practice purpose, it's always a good idea to create a temporary pod where you just want to see whether your pods from the deployments are accessible. So just make a temporary pod with an wait a second, I've got something in with an Alpine curler, just add your IP address from your pod. And as you can see, now the deployment is up and running. We can access our web server. We see WebMoon web page. So everything is great. Now we can go on. Next slide, please. This was it about configuration. And I hope you can see these tasks are not difficult. You need to know what you do here. You need to practice and you need to be fast, but they are not difficult. Definitely not. Next topic, multi-container pods. It's very likely that you see something like that. I don't want to lose too much words about it because they are very obvious. You need to create a pod with multiple containers. In most of the cases, these are two, one main container and one sidecar container. In this example, we have a BusyBox pod with a command here, which just executes every 5 seconds, hi, I'm from main container, and redirects that output to a file, and do this again and again. On the sidecar container is just another container with exposed on port 80 with an empty directory as a volume and some additional information. I won't go too deep into that. Next slide, please. So unfortunately, it's not possible to create, for my knowledge, it's not possible to create multi-container pods with an imperative command. So just create one with one container, then we can adjust the YAML file. Flo, could you go to the next slide? Here we can just copy paste our container specification for the main container and add some information to the sidecar container. So one advice from my side, it is very, very useful to know how to copy and paste and delete stuff in Vim. It's not difficult. You just need to Google it one time, and then you know how to do that. And it can save you minutes in that axiom when you know how to copy and paste stuff in these files. So just use a multi-container pod with one main container, one sidecar container, and you're good to go. Then you deploy your object and you're done. Yeah, thanks. Next one. It's very likely that you see something like readiness probes and liveness probes. Next one, please. In this case, you have to add a readiness probe to your container, to your pod. Here you need to create a new pod called pod 6 in the default namespace with that given image here. And for a readiness probe, you should execute cut, temp, and ready. And you should wait you should wait in the first place, you should wait 5 seconds, and then you should execute it again and again every 10 seconds. And this is basically your readiness probe. And we have seen that. Next slide, please. You can just create a pod with an imperative command here. You can give all the information that is needed. And then you can adapt your YAML file. And as you can see, you see these commands at the bottom of this file here. Just add the readiness probe. Flo has said we have one additional tab for the documentation. So if you are not sure about readiness probes and what exactly is required here, just have a look at the documentation, copy that stuff, paste it in very quickly, and then you can add a readiness probe to your pod. After that, you can just deploy your pod to your cluster and you're done with this exercise. So you see, it's not a big deal here. Then we can double check whether our pod was deployed correctly. And then we see the ready counter increments to 1. The pod is up and running. And this is the best thing you can see in the axiom. Then you know you can go to the next exercise here. Yeah, pod design, this basically covers deployments. You will definitely see something like something related to deployment, rolling updates, or rollbacks. In this exercise, we already have a deployment called API new C32 in the Neptune namespace. And it seems like there was something incorrectly. If you go to the next slide, Flo, to the next slide, please. Then you see that you have in your history some rollouts here. You have 4 rollouts. This is always a good idea to have a look at your history of the deployment, and you see that you have changed the image in your deployment or some other attribute 4 times, and that you can see in your history here. Next slide. Unfortunately, the latest update of the deployment created some error here. And if we pick out one of the pods, this is very essential here. You need to have a look at the replica set. You need to see your pods, pick one out, and then you see, oops, there seems to be an image pullback off. So something is wrong with that image here. And in this exercise, it was the case that you just need to revert the latest change that you redo the latest update to the image to go to another version. In this case, I don't know, there was, I think, a typo in the image, I think. And once you have rollout, you have undone your rollout, you have done your rollback here, then you see all 3 pods from your deployments are up and running and you're good to go. In most of the cases, it's something like that. Some typo in the image, maybe you need to correct that, or you need to revert your rollout. So this is easy. Next one. Yeah, then we are almost done with the axiom. Another important topic are services. Next slide. For this exercise, you need to create a service and you need to create a pod. And that pod is supposed to be exposed by that service. This is basically it. It's very likely that you will see something like that in the axiom here. So don't bother with the details here. I will give you a brief introduction what to do here. Next slide, please. First of all, we need a pod. And as you might seen that before, we just can use imperative commands in the Pluto namespace. The project PLT 6cc API is the name of our pod, and we use an Alpine, an Nginx Alpine image for that. And what is very cool about that, we can provide some labels here. There is no need to adjust our YAML files for that. We can just provide our labels in that imperative command. So once our pod is up and running, and this is the YAML file, and imagine you would have the pain to write it in the XM. You don't have the time for that, so don't use that. Learn these imperative commands by heart, and you're good to go. Next slide. Then we need to expose our pod by in service, and there are multiple ways to do that. The easiest way, since we only have one pod here, is to say, I want to expose my pod with the name, etc., etc., with a service called project PLT 6cc service on port 3333, and my target port of the pod is 80. And that's it. This is basically the solution for this exercise. Another way to do this is to create a pod service on its own, but this has the drawback that, of course, maybe some of you know that, if you create a pod like that, you need to adjust the selectors of that service, because for now the service does not know which two pods to cover, so you need to adjust the selector here. If you do the first solution, this is the easiest one, but you can also do it as well. If you know what you do, just do it like that, it's fine. And then I always recommend to do that in the XM. If you work with services or you just fix some problem with networking, always have a look at your endpoints. Don't forget your namespace. We are in the Pluto namespace here. And there you can get your endpoints, and you can see our service has one endpoint with port 80. So everything is good to go. The service exposes our pod. So this is our proof. We can go on here. Yeah, and then we are almost done. Very likely the last exercise of the XM will be something with state persistence. You can absolutely sure about that. So we don't go into the deep details. I just added these texts here just to let you know to what scope the descriptions of these tasks look like. So what do we have to do? First, we create a persistent volume in the Earth namespace, I think. No, persistent volumes are not bounded to namespaces, so we can leave that information away. And always make sure that you have the right properties of that object. That means in this case, you need a capacity of 2GI. The access mode is always read-write once. You won't see any difference, but you need to provide that information and your host path here. Then you need to create a persistent volume claim. This needs the information of a namespace here. And this information for the persistent volume claim should comply with the persistent volume. And after that, you need to create a deployment which mounts this persistent volume. So how can we do that? And Flo, next slide. And here it is very important that that you be aware of one thing. For the time being, it's not possible to create persistent volumes or persistent volume claims with imperative commands. I don't know why this is why this is the case. Maybe there is some advanced reason for that. I don't understand. But for that, you are not able to provide imperative command. So since Flo has said that before, you have the opportunity to open one additional tab with the Kubernetes documentation in it. And there you can just search for the persistent volume. Maybe you can just bookmark them beforehand, then you can access them very quickly. And then you just can copy and paste that template you find in the documentation here. Paste it in your YAML file, adapt the information, delete unnecessary stuff, and you're good to go. Again, do not write YAML files from scratch. It takes too much time, and especially for this amount of information, just copy and paste for persistent volume. Next slide, please. And the same holds for persistent volume claims. Just copy the template from the documentation, paste it in here, and you're good to go. I did it the same way. And to be honest, yeah, I would definitely not have enough time to do that. After that, as a little checkup, you can just get the information for your PV on your PVC. And if you see something like bound, you can be very happy, because that means that your persistent volume is bounded to your persistent volume claim. And so everything runs smoothly. For the last exercise, remember, you need to create a deployment where you need to mount that volume, that persistent volume claim. So again, it's always the same story. Write a imperative command to create a deployment and redirect that YAML information to that file, because you need to adapt this file. You don't have the mounting information yet, and you want to alter it. So here you see that comments here with the add. You need some volume information to your pod template here. You need to provide the information where to find it. In this case, it's the name of the persistent volume claim. And of course, you need to mount that persistent volume claim to your container here. And this can be done with the volume mounts directive, with the name data here. And in the best case, everything works smoothly and you can start your deployment. So next slide, please. And that's it. This is basically the whole coverage of the CKAD. You see, the task, if you practice, the task won't be difficult. The only problem, as Flo mentioned before, is the time boxing here. You need to be fast, you need to be quick, you need to be, you have to know your imperative commands by heart, because you won't have the possibility to take them with you in the exam, but it's not a big deal. So next one are a couple of words about the debugging. Often you have the task to repair something in the Kubernetes cluster. And for that, I give you some advices, which you can, I don't know, screenshot or something. The first thing is a good idea to get a list of all your namespaces. Where can be objects? Then list all your pods. This is the key here. List all your pods, in the best case, in all your namespaces, because then you can just have a look at the status of different pods. And if you see something like image pulled back off or error, or I don't know, something like that, then you know, okay, there has to be the problem, and then I can investigate further. Then if you have located your corrupted pod, you can get the description of it. Maybe there is some event which tells you something about the error, or as an alternative, you can just have a look at the logs of a specific pod. Yeah, container, sorry. Next one, change pods. Sometimes you have to change pods. For some properties of a pod, you can just edit the YAML file, but sometimes this is not possible. So you need to create a completely new pod for that. So this is my recipe for that. Just get the information of that pod, the specification, and output in YAML format and redirect that information to a file. You definitely don't want to lose the pod here, because once it is gone, the only possibility here is to restart your cluster, and this is not a good idea. So just save it to be safe here in a YAML file, and then you can delete your old pod, alter the information in your mypod.yaml, and you can deploy it again. So you're good to go. And as a final word, next one, please. Sometimes you have to deal with, I had to do that in my exam, to troubleshoot access issues. Maybe you have something like a network policy, you have some pods here, and because of some reasons, pods don't have access to something, or they should have, or they shouldn't have access to something, and we want to block that. In these cases, I'm absolutely sure you have two scenarios here. The one is that the pod is missing some labels, that you need to provide some labels such that the network policy allows the pod to access something else. Or you need to reconfigure your network policy where you add some ingress or add some egress to make sure that your pods have access to any other resource which is restricted here. So this is it about debugging. You will definitely make use of these tools here to walk properly through the cluster here. So thanks. Next slide, I think I can hand over to Flo. He will give you some advice for the preparation.
So first, could please the co-host who scribbled on the slides, please try to remove that again, because I don't know how, and I don't think I can do that. So first, regarding learning material, like I said, you don't really get great material from the CNCF itself. So there are two famous courses, one on Udemy, one on Linux Academy. They are both good. They teach you in about, I don't know, 8 hours of video material, the theoretical basics. But what's more important, they also give you some training labs where you have a very similar environment to the real exam, and you can practice some smaller exercises. And you can do that as often as you want. That's really nice about them. Then, yeah, Carsten already mentioned that. That's something very basic, which every tutorial for the CKAD exam tells you. Just create bookmarks for every topic that is relevant for the exam itself. Because you're just allowed to use one tab, but you can have bookmarks in that tab. That's no problem. So that also saves you a lot of time. Then there are two special parts of the Kubernetes documentation which are really, really helpful during the exercise or the exams. First, the API documentation. Here you can look up for each existing Kubernetes objects, how are the fields called if you forget them. For example, here are all the K8 objects. You can find everything that you can deploy via YAML here. And here you find, for example, the container definition has a field called command, and it's an array of strings. So you'll find the name and the type if you can't remember that. Or what's even better, for example, the readinessProbe, it's not just a simple value that's itself a complex object. You can also find a link here that leads you to the next description of this readinessProbe object, where you have each field of the readinessProbe object. So if you can't remember one field name, you can easily find that in that documentation. But it's costly from a time perspective. So this is really good during preparation, but I wouldn't use it that much during the exam itself, because you probably don't have the time. The CLI documentation, that's really like cheating. I really like that. First, you can find here every existing kubectl command. So the thing is, it's enough to know most of the commands that are relevant for the exam. You don't have to know everything about the command, and especially the imperative command, because, so here in the middle, you have some close-up description of the different flags for the command. But the cheating part, and it's not cheating, it's completely allowed because it's part of the Kubernetes documentation. You have here example imperative commands. And for a lot of the easier and smaller exercises, you find the correct command already prepared here. So you just have to copy that and change, let's say, the name of the deployment or of some flag. But in general, you get the commands you need here. And even if you need more than that command does, you can just add the missing flag, and you are done in less than a minute with an exercise. And then, of course, like you probably realized now, even if you study really, really hard, it's not easy to really prepare without practical exercise. And some smart businessmen also realized that. And therefore, we have now two sites that provide exam simulators. So you can do a complete simulated CKAD or whatever exam here. That's the first one. It's called killer.sh. The thing is, that exam is a little bit harder than the real one. So you could be a little bit scared if you do it the first time, but it's a good preparation. It's a full 2-hour session like the real exam. So you have 2 hours and then shut off. You get also 2 simulator sessions for, I think, $30 or something like that. The only sad part here is they only have 1 exam. So it's, and also the example exercises Klaus showed you, they were copied from their 1 exam, for example. So you can do 2 times the same exam. It's not that useless because for the first time, you're probably not used to that, so you will miserably fail. You will be too slow, you won't get every exercise done, but later you also get a complete solution for each exercise. And then you can try it a second time and try to be as fast as possible to also be prepared for the real exam. And then there's another site, it's newer, it's the underdog of these simulators. It's called KubeWiz. And their difficulty is much closer to the real exam. They have also the idea, I talked a little bit to their sales guy, therefore I know that stuff. The idea is to have smaller sessions because most people don't have or don't want to spend 2 hours and then probably additional 2 hours to review their exam practice. So they offer smaller sessions so you don't need to spend the whole evening practicing. Then, yeah, you also get multiple of these smaller simulator sessions if you buy that. And the really nice part is, similar to the real exam, they have randomly generated smaller sessions. So you get a random set of exercises, which is cool, I think. Yeah, that's it about it. That are the 2 available simulators. And at the end, a short resume from our side. So what is our opinion about CKAD after doing it? So first, we both had the opinion it is hard but fair. The hard part is just the time limit. The exercises itself, there are no shady exercises that try to trick you into doing something wrong or something like that. They are really doable, but the time pressure is hard. It was really fun, especially if I compare that with that boring multiple choice exams you have to do for Azure or AWS. I really prefer these exams. I had really fun to prepare for the exam. I think Klaus also. And yeah, that's also my personal opinion from 2 sides. First, I think the certificate provides real value because if you're new to Kubernetes and want to prepare, for example, for a Kubernetes project, it's a really good idea to do this certificate. It will prepare you. But like I said, I'm also part of the HR department and I do a lot of technical interviews. And if one candidate would have that certificate, I would trust him to be able to work in a Kubernetes project. So it's also, for me, from an HR perspective, very interesting to see the certificate with candidates.